How to calculate triangular arbitrage. In this presentation, I will explain how triangular arbitrage works and how to calculate whether a profitable opportunity exists. Triangular arbitrage involves converting one currency into a second currency, then into a third currency, and finally back into the original currency. If you finish with more of the original currency than you started with, the difference represents an arbitrage profit. The basic calculation is simple. Multiply the conversion rate from each of the three trades. If the resulting profit factor is greater than 1 after transaction costs, an arbitrage opportunity exists. Let's dive in. The quantitative approach focuses on the relationship between three different exchange rates in a single loop. For example, the direct euro to pound exchange rate should match the synthetic euro to pound rate, calculated using the euro to dollar and pound to dollar markets. When the direct and synthetic rates are different, one route may allow us to buy a currency more cheaply than the other. We can then complete a three-currency loop and potentially return to our starting currency with a profit. The key test is the loop return. If the loop return is greater than 1 after spreads and fees, the trade is profitable. In a stable market, the direct exchange rate between two currencies should match the rate implied by a third currency. We have established the logic of consistency. Now we will walk through the 4 steps to identify and calculate these trades. Step 1. Normalize the quotes. The first step is to make sure every exchange rate points in the same direction as the trade we want to execute. For example, EUR/USD at 1.1000 means that 1 euro is worth $1.10. If we are converting euros into dollars, we multiply by 1.10000. If we are converting dollars into euros, we divide by 1.1000 or multiply by its reciprocal. This is one of the most common sources of mistakes in triangular arbitrage calculations. We must pay attention to which currency is the base currency and which is the quote currency. We can also calculate a synthetic cross rate using 2 other currency pairs. For example, the implied Euro-GBP rate equals Euro-USD divided by GBP-USD. Once all rates are expressed in the direction of the intended trades, we can compare the direct rate with the synthetic rate. Step 2. Compare direct and synthetic rates. Now consider 3 market quotes. EUR/USD is 1.1000. GBP-USD is 1.2500. The directly quoted EUR/GBP rate is 0.8700. Using the 2 dollar-based currency pairs, we can calculate the synthetic EUR/GBP rate. We divide 1.100 by 1.2500, which gives us 0.88000. The synthetic market therefore values 1 euro at 0.88 pounds, while the direct market allows us to buy 1 euro for only 0.87 pounds. This tells us that the euro is relatively underpriced in the direct EUR/GBP market. The profitable direction is therefore to obtain pounds, use those pounds to buy euros, and then convert the euros back into dollars. With the trade identified, we can now model the actual execution and the resulting return on capital. Step 3. Execute the profitable loop. Let's start with $100,000. First, we convert dollars into pounds. Because GBP-USD is 1.2500, we divide $100,000 by 1.2500. This gives us 80,000 pounds. Next, we convert the 80,000 pounds into euros. Because Euro-GBP is 0.8700, we divide 80,000 by 0.8700. This gives us approximately 91,954 euros. Finally, we convert those euros back into dollars. We multiply 91,954 euros by the Euro-USD rate of 1.1000. We finish with approximately $101,149. We started with $100,000, so the gross arbitrage profit is approximately $1,149, or 1.15%. The same result can be calculated using the return factor. We divide 1.1000 by the product of 1.25000 and 0.8700. The result is 1.01149. Because this is greater than 1, the loop produces a gross profit. Step 4. Use bid and ask prices. The previous example uses single exchange rates to make the calculation easy to understand. In the real market, however, traders cannot normally transact at the midpoint price. Every currency pair has a bid price and an ask price. When we buy the base currency, we normally transact at the ask. When we sell the base currency, we normally transact at the bid. Using midpoint prices can create the appearance of an arbitrage opportunity that cannot actually be executed. The complete currency loop must therefore be calculated using executable bid and ask prices. The final return must also cover brokerage fees, trading commissions, liquidity costs, and possible price movement while the trades are being executed. A theoretical return greater than 1 is not enough. The return must be greater than 1 after all costs. Trade size is also limited by the amount of currency available at the quoted prices. The spreadsheet formula triangular arbitrage is easy to calculate in a spreadsheet when every conversion is expressed as a multiplier. For each leg of the trade, determine the correct conversion multiplier. If the exchange rate quote points in the same direction as the trade, we may multiply by the quoted rate. If it points in the opposite direction, we use the reciprocal of the rate. We then multiply the 3 conversion multipliers together. The loop return equals multiplier 1, multiplied by multiplier 2, multiplied by multiplier 3. Profit percentage equals the loop return minus 1. The final portfolio value equals the starting amount multiplied by the loop return. In Excel or Google Sheets, we can also use an if statement. If the loop return is greater than 1 plus estimated transaction costs, the spreadsheet can identify the trade as potentially profitable. Otherwise, there is no executable arbitrage opportunity. Recap. To calculate triangular arbitrage, begin by normalizing all exchange rates into the direction of the intended trades. Next, calculate the synthetic cross rate and compare it with the directly quoted exchange rate. Use the difference to determine which direction around the currency triangle may be profitable. Then convert the starting currency into the second currency currency into the third currency, and the third currency back into the starting currency. Multiply all 3 conversion factors together. If the final loop return is greater than 1 after bid and ask spreads, fees, and other execution costs, a triangular arbitrage opportunity exists. In real foreign exchange markets, these opportunities are usually extremely small and disappear quickly because automated trading systems continuously search for and correct exchange rate inconsistencies.